Yep, it's working now. Okay, so x squared over 2. And of course you would say natural log of the absolute value of x from 1 to e. There is no need though for the absolute value of x, the absolute value symbol, because this is positive, both of them. Okay, so then when I plug in e, I have e squared over 2 plus, anyone remembers natural log e?
1.
Yes, great job. 1 minus, when I plug in 1, I have 1/2 plus natural log 1. Anyone remembers natural log 1?
0.
Perfect. So then the final answer will be e squared over 2 plus 1 minus 1/2, because this is 0. 1 minus 1/2 is 1/2, so this is e squared plus 1 divided by 2. Okay, so let's take a look at some applications. Let's see accumulated sales. 64 on the same page, 402. Feel free to choose anything from this page, anything you want. So Melanie's Craft estimates that its sales are growing continuously at a rate given by, okay, this is the rate of change, s prime of t equals 20 e to t. Where S prime is in dollars per day, of course, it's a rate of change, dollars per day. This is the measurement unit for this. On day T, so T is in days. Perfect. Find the accumulated sales for the first 5 days. So sales for 0 to 5 days. Can anyone tell us how to write this, or what does it mean, and how do I calculate this? Anyone? It's okay if you're wrong. Don't worry about it.
You have to do the function for each number between 0 and 5 added, and then it would be times.
So it's the integral. It's the integral from 0 to 5 from 20 e to t dt. It's a constant, it goes in front. The integral from 0 to 5 e to t dt. So this is 20 times. What is the what function I differentiate to get e to t? Of course, we love that, isn't it? Okay, from 0 to 5. Good. So 20, I should put it in parentheses like this, because I want to leave 20 outside as we did with the areas. I don't want to involve 20 till I finish. So this is 20. E to 5 minus e to 0. But how much is e to 0? Any number raised to 0, not 0 raised to 0. But any number raised to 0 is 1, except 0 raised to 0. So let's calculate this. So I have 20 in parentheses e to the 5th power and minus 1. So I get 2948. 2948.26. Any questions on this before we move on to part B? Okay, part B. We're asked now to determine, that's my page 7. In part B, they're asking us to determine, find the sales from the 2nd day through the 5th day. So from the 2nd through the 5th day, that will mean the integral from 1 to 5 in order to include 2, we have to start at 1. Of the same thing, 20 e to t dt. It's still 20 outside, it's still e to t, it's still from this situation from limits 1 through 5, still 20 is outside, and this is e to the 5th power minus e. So let's see what we get. So all I have to do is just repeat with e in here and just press enter. 2913.90. And in this way we can calculate anything we need, any sales. Once we have the rate of change of sales, we're given the rate of change of sales. Moving on, do you have other preferences? Do you want to look at other problems here, or we continue?
Could you do number 46?
Let's look at 46. Very good. 46. 46. Yes, perfect. 46 is the integral from 1 through 8 from the cube root of x minus 2 dx. Is this, did I choose the correct one?
Yes.
Perfect. So the trick here is to remember how to replace this by x to power 1/3. If we remember that x to power 1/3 is the cube root of x, this becomes quite a simple situation. So this is the integral from 1 to 8 from x to 1/3 minus 2 dx. And now I have to find the antiderivative of this. What function prime gives us x to 1/3? And remember, we have to increase the power by 1 and divide by the result. So you can write it like this: 1/3 plus 1 over 1/3 plus 1, and we'll come back to it. And then minus 2 times x, because 2x prime is negative 2x prime is negative 2. So this is from 1 to 8. So 1/3 plus 1 is 3 plus 1, so this is 4/3, and divided by 4/3. But I have to flip now 4/3 in front. 3 over 4 multiplied by x to 4 over 3 minus 2x from 1 to 8. I plug in 8 everywhere, and I subtract when I plug in 1. It is safe to write it like this. And then minus when I plug in 1. 3 over 4 minus 2. Why is it safe to put not this one but this one in parentheses? Because remember, you have to distribute -1. And you may forget to distribute it to the second number if you don't put parentheses. I'm not saying you will, but I'm saying you may. So next, I can see if, so this is the cube root of 8 to the 4th power, so it's basically 2 to the 4th. I can show you how. It's 2 to the 4th. So 2 to the 4th will be 16. So you can enter it as 8 to the power in parentheses 4 divided by 3. So it's 3 to the 4th. It's 2 to the 4th, I'm sorry, which is 16. So that's how we simplify it. Or we can simplify it with a calculator and you get 16. So this is 16. So 3 over 4, 16. So I simplify 4 and 16, I get 4. So this is 12. Minus 16. Minus 3 over 4 and plus 2. So of course I'm going to calculate these first. So 12 plus 2 is 14. 14 minus 16 is -2 minus 3 over 4. So this is a negative number. 4 times 2 is 8 plus 3 is 11 over 4. Very good pick. Do you have any other that you would like to look at?
Can we do another one that has a radical?
Yes. We can make one up, or we can look at, if you'd like, 45 or 58 or 57. I see they have radicals. It's up to you.
57.
58. So we have the integral from the square root of 3x. Very good pick. So 58. And that's still on 402. So the integral from 0 to 27, the square root of 3x dx. Remember, the square root of 3x is the same with the square root of 3 times the square root of x. Very important to understand that, because I'm going to take the square root of 3 outside. I'll say 0 to 27. And this, I have to remember that the square root of x is x to power 1/2. So x to power 1/2 and dx. So now this is set up for integration. So the square root of 3 times x to 1/2 plus 1 over 1/2 plus 1 from 0 to 27. I know that this is 3/2 and this is 3/2, so I have the square root of 3. 3/2 gets flipped into 2/3, and x to 3/2 from 0 to 27. We will plug in 27 and we subtract when we plug in 0. I will not do that because when I plug in 0, it will be 0. So then it's 2 the square root of 3 over 3 multiplied by 27 raised to 3/2. Okay, now I have to be careful because this is not exact and I have to simplify it in a different way. So 2 the square root of 3 over 3, this, 27. 27 to 3/2 is the square root of 27 to the 3rd, or the square root of 27 to the 3rd. Both mean the same thing. But the square root of 27 is 9 and 3, right? So the square root of 27 is 3 the square root of 3 to the 3rd power. So this is times 3 to the 3rd power times the square root of 3 to the 3rd power. Okay, so now I have 2. I'll put 3 to the 3rd power, which is 27, divided by 3, times the square root of 3, times the square root of 3 to the 3rd is the square root of 3 times the square root of 3 times the square root of 3, but this is 3. So the square root of 3 is this, and this is 3 the square root of 3. Nice. These two go away. This is another 3. So I have 3 times 27 is 81 times 2, 162. Any questions on this problem? Some of them, look, it took me, and also I needed to explain what I was doing. So some of them can be a little bit cumbersome with the numbers. I know I have roughly about 12 minutes left. I'd like to finally go back to what they presented in section 4.1, which is not, there was no place for that at the beginning of the chapter. Okay, so integrals are of two types. One that we've been playing with for this week, right, for a couple of days, which is the definite integral. All these, this is a definite integral, definite. It has a lower limit and an upper limit. And the answer is a number, always. So a definite integral, I'm also going to write it here as an example. The integral from 1 to 4 from x squared dx. And this will be a number. So this will be x to the 3rd over 3, evaluated from 1 to 4, and I will get a number. It's also the area under x squared between 1 and 4, and so on and so forth. Now the other type, the second type of integral, is not definite. It's indefinite. The indefinite integral does not have limits of integration. It's, for example, the integral from x squared dx. And we know that the answer is x to the third over 3 plus a constant c. This is the most general antiderivative. And this is never a number, a function, or to be exact, family of functions. Because if c is 1, I have a function. If c is 2, I have another function. If c is negative 100, I have another function. Here, I could never, whatever number I get, I cannot check. There is no way of checking other than doing it again to make sure I get the same answer. But here I can check. I can always check the answer for an indefinite integral. How? By differentiating both sides. When I differentiate an integral, the operations are inverses of each other. I only get the function. When I differentiate this, I bring down 3, I simplify, and I get x squared. C prime is 0. So this is how I check. So indefinite integrals will always give us a function or family of functions, or the most general antiderivative. The definite integral will always give us an area or a number, if you want. So now we are ready to practice this. So please let's return to page 378. I couldn't have started with this. I mean, it doesn't make any sense. I had to explain what a definite integral is and how we calculate the area, and then explain how we get a function from the indefinite integral. I couldn't do that at first. So anything you like to choose from 1 through 46. Anything you want. Till you open the page, that page, I'm just going to choose one. Let's say 40, and then I'll wait for you to choose. Page 379, and 40 reads the integral, indefinite integral, x to the 4th, plus 1 over 8 the square root of x, minus 4/5. Make sure I'm not copying from 2 problems, although it wouldn't be any problem though. Okay, so I'm checking. X to the 4th, yes. 1 over 8 the square root, yes. Negative 4, yep. Okay. So we know that the result is a function, and we know that if we want to check, we can always check. Okay? What function prime is x to the 4th?
X to the 5th over 5.
Excellent. Plus 1 over 8. Leave 1 over 8 alone and change this into 1 over 8 times x to negative 1 over 2. The square root is in the denominator. So now I brought it to the top, but I have to change the sign of the power. So this will be x to negative 1/2 plus 1 over negative 1/2 plus 1. It has to be the same number. Then I copy negative 4/5, and I do the same thing with this as negative 2/5 plus 1 over negative 2/5 plus 1. I cannot stop here. I need this. Plus a constant c for the most general antiderivative. Yes, I have to clean it up and present it nicely, but that's the final answer. This is the function or the family of functions whose derivative is this. Guaranteed. But yes, it needs to be cleaned up, those numbers, and simplify the fractions. Okay, so x to the 5th over 5 will stay. This is negative 1/2 plus 1 is 1 over 2, but I have to flip it. So it's 2 over 1 plus 1 over 8 times 2 over 1 times x to 1/2. You can change this into the square root of x now if you want to, it's fine. Then negative 4, I'm going to write it one more time and simplify anyway. So 2 over 5, negative 2 over 5 plus 1 will be 3 over 5, but I have to flip 3 over 5 into 5 over 3 times x to 5 over 3. See, I don't have to calculate this twice, it's the same number, so plus a constant c. Okay, it still needs cleaning up, so this is 4 here, and these two go away. So, x to the 5th over 5 plus 1/4 the square root of x minus 4/3, and you can keep x to 5/3 as is, plus a constant c. If you want to check, we can. Now please